So students, now we have already seen that in the previous slide that this was the new point. Now this is the secant line here. Let me use the pointer here so that you can better understand. So students, by intersecting these 2 points, so x2 and x1, so we have this secant line, and this secant line cuts the x-axis at this point, x3. So what happens, students? So this is now your new point of iteration. And if you see corresponding to this curve, so this is the point. So this yellow color point is the new point. So this is the x3 point. So students, now just take the previous point and this point and join these 2 points. And if you join these 2 points, so you see that this secant line cuts the x-axis very close to the actual root. So this new point, basically this new point is your very good approximate root, and this one is very close to the actual root. So students, in this way you can very easily calculate or find out the approximate root by using this method. uh, do the uh, evaluation or the derivation of the formula. So students, here this is written by mistake. uh, it should not be to the point slope formula. It should be basically the 2 point form. So let me correct this one, otherwise maybe you can make a mistake. So let me delete this one. So students, make it clear that this is not the point slope form. This is basically the formula for the uh, formula for the straight line using 2 points, or you can say that this is the 2 point form of the straight line equation. So students, now actually now we are actually heading towards the derivation of the secant method. So what we are going to do is that since we had just like the Newton method, we have basically now the secant line here, and this secant line cuts this axis at this point. So what we are going to, let's first write the equation. Okay, so this is the equation of the straight line, and these are the 2 points. So what is the equation of the straight line? So y minus y1 is equal to y1 minus y0 over x1 minus x0, x minus x1, or simply y minus f of x1 is equal to f of x1 minus f of x0 over x1 minus x0 into x minus x1. As students, this is very important to note here that in the beginning you don't know what should be the point x0 or x1, so you can take any point. So whatever the points is, the equation of the straight line will remain the same. So no problem whether this is x1 or x0. So if you take x0, x1 to the first point and x0 should be the second, maybe the second point, even then there will be no difference in the equation of the straight line. So now we are going towards the derivation of the secant method. So just like in the case of Newton method, so we had considered the case when this line touches this axis. So similarly here, so this secant line touches the x-axis. Right, so you can see that this is the point here. This is the new point here, and this point we have given the notation to be x2, whereas y is equal to 0 at this point. So student, this was the again this should be this is the continuation actually of the previous slide. So this should not be the point slope formula, so this should be the 2 point form for the equation of the straight line. So inshallah, in the slides I will make it correct. So students, now to find where this crosses the axis, we set y is equal to 0 and x is equal to x2. So just substitute the value of y to be 0, and students, here this is x, so instead of x, so this is x2. Other remaining things are the same, so no problem at all. So students, now what we are going to do is basically our idea is to find this point, the new point x2. So in this case, I am going to evaluate this value of x2. So students, just make some simplifications. You just multiply this factor on the other side and divide this factor, I'm sorry, on this other on the other side, and make it in the denominator, and just put it on the other side, this x1. So this one becomes as x2 is equal to x1 minus f of x1 into x1 minus x naught over x of x1 minus f of x naught. So student, this is the next point. So see, initially we had only 2 points, x naught and x1. But now you have made the first iteration, and that is x2, and this is the formula for the next iteration. So on the similar lines, students, so we can calculate the value of x3. So what is x3 now? So x3 is equal to, just add in 1 in the subscripts. So x3, so here x2, here x2. So x2 minus x1 over f of x2 minus f of x1. And students, we can make the general formula for this, and that general formula is xn plus 1 is equal to xn minus f of xn into xn minus xn minus 1 over f of xn minus f of xn minus 1. And if you want to calculate the value of xn only, so here it would be, just subtract one value here, xn minus 1, so here xn minus 1, so n minus 1, but here it should be xn minus 2. So similarly you can change the other value. So students, this was all about the derivation of the secant method. So you can simply make it this general formula, and you can solve the question by this formula. Students, now let's do the example here, and actually this example was taken uh, in the secant sorry, bisection method as well, and in the Newton method as well. We solved this, the same equation, the same function in both methods, and now I'm just using the same example for the secant method as well. So but now in this case, students, we have to consider the 2 points, and I guess in the bisection method we use the same points. So let's take the same points, x naught is equal to 0 and x1 is equal to 1, but this doesn't matter at all. You can take any 2 points, no problem at all. So you just take 2 points and then start using the formula for the secant method and find out the new iterations. So students, here in this case, x2 is equal to x1 minus f of x1 and into x1 minus x naught divided by f of x1 minus f of x naught. So now students, so no derivative is involved, so just find out the function values and substitute here in this formula, and you get this answer. And students, now x3 here, the next iteration. So on the similar line, so the similar formula, so you get this value 0.6766. So similarly, students, you can find the other iteration, and if we can continue in this way, so you get these values. uh, when n is equal to 0, so xn is equal to this one. For n is equal to 1, so have the first these are the first two initial guesses. So 0 for 0 and 1, so 0 and 1 are the two initial guesses. So the second iteration gives you this value, the third iteration gives you this value, fourth this one, fifth this one, sixth this one, and seventh this one. Similarly, you can find out the other value. Student, here this is the column, this is not relevant to you in the sense that basically alpha is the exact value. This alpha was the exact answer, exact value of the root, but in your questions normally it is not given, you don't know about the exact value. So how to stop this one? Just like the Newton's method, like xn plus 1 minus xn, and this mod value should be less than the tolerance. So students, we will discuss inshallah in the coming slides, so how to stop this secant method. but for you maybe this is not very much relevant, because if you are given the exact root, then you can use make this column. Otherwise you don't need to do this. You just need to use the normal procedure to find out whether the difference of the previous iteration and the new iteration is less than the tolerance or not, uh, as just like the Newton's methods case. This was actually all about the secant method, but for your course contents there is another method, and that is method of false position. And or you can say that this is also called as the Regula Falsi method. Students, um, I I connected this method secant method with this method, or you can say I connected this Regula Falsi method with the secant method. And the reason behind is this is very close to the secant method, very similar to the secant method. There is a only one small difference. So that's why even uh, in the book which we are going to follow, which we are following, uh, in that book the Regula Falsi method is not separately given in one or two lines. So this method is clearly is given actually, and not with the with this heading, with this method of false position or the Regular Falsi method. So in the just the comment, there is one line written there. So students, we can simply and quickly move to this method, and we can finish this one. So what it says, so in bullet points I have mentioned 3 points here. First of all, this is very similar to the secant method. Secondly, the working formula is same as the secant method. And students, uh, a variation on the bisection. This is the last point. The last point is very important. And this is the only difference between the secant method and the bisection method. What it says that a variation on the bisection method is known as Regula Falsi. What does it mean, students? Student means that basically just like the bisection method, and we just make a small variation using the secant method, it gives you the Regula Falsi method. And what is the main, it means what is the main difference between the secant method? You know, in the case of secant method, we didn't bother whether the function value is positive or negative. We just took the 2 points, and uh, I just used these two initial guesses, and then I proceeded to the next iteration. But for the case of Regula Falsi method, or for the method of false position, we need to choose the two initial guesses in this way, that one point gives the positive function value and the second point gives you the second initial value. So in this way you proceed. And the second thing is, once you have these 2 points, and then we proceed with the same secant method. But in the case of secant method, you just proceed with the just previous value. But for the Regula Falsi method, it is very important that the last point and the previous point, they should have the, if the last two iterations have are giving, the 2 points are giving the positive function values, for example, so just take the last value and the previous that value which gives you the negative value, just like the bisection method. Okay, so student, I will go back to the slide to show you in further details. But before going to that slide, see how to stop secant method or the Regula Falsi method. So students, just like the Newton's method, what we are going to do is uh, we use the similar procedure. We have the previous iteration and we have the new iteration, and the tolerance value is given. So xn plus 1 minus xn should be less than or equal to the absolute tolerance value. This absolute value should be less than or equal to tolerance. For example, students, if we have the value of the tolerance to be 0.001 or maybe 10 raised to the power minus 3. So if the difference between the previous iteration and the new iterated value So or the approximated roots is less than epsilon or the tolerance, then you should stop. Otherwise you should move to the next uh, iteration. Okay student, I think before just going to this one, let's move to the previous slide to further go into the details of the uh, regular Falsi method.